Here are your notes for section 1, 2, and 3 for the Alice packet. In section 1, we can see here the definition of exponent. Exponents are used for repeated multiplication of the same thing. You have the large number is the base. Your superscript is the exponent. Your example, 2 to the 6th, means 2 times 2 times 2 times 2 times 2. On section 2, we have the zero property power. Anything to the zero power is 1, except for 0 to the 0, which is undefined. And that's the exception that we were talking about during class. So, for example, Alice ate 0 ounces of base 2 cake. This can be represented by 2 to the 0. Alice won't grow, so we will multiply her height by 1. Thus, it makes sense 2 to the 0 equals 1. So we have some examples to go through. X to the 0. Even if we don't know the base, we know x to the 0 would equal 1. And on this next example, we have the whole quantity 3x to the 4th times y, all to the 0 power. Again, because the parentheses are here, everything would equal 1, which is slightly different than the third example here. 5 times x to the 0 times y to the 3rd. The 0 power only goes with the x. If you want to write that down. So if an exponent is not present, it is a 1. So this 5 has its own exponent of 1. So it's 5 to the 1st, x to the 0, and y to the 3rd. So the x to the 0 turns into 1. So then we have 5 to the 1st times 1 times y to the 3rd. And in simplest form, this is now 5 times y to the 3rd. So make sure you understand the difference between the second example and the third example. We'll practice that some more in class. Moving on to section 3. Section 3, powers of powers, or the additive law. This went along with piece after piece activity. When multiplying 2 powers of the same base, the shortcut is to keep the base and add the powers. So the story an example of Alice here is Alice ate 3 ounces of base 2 cake, watched TV, and then ate 4 more ounces of the same base 2 cake. So base 2 cake means that Alice is doubling each time. So 2 to the 3rd times 2 to the 4th is going to equal 2, is going to be the same as 2 to the 7th. So same base, add. 2 to the 3rd times 2 to the 4th is the same as 2 to the 7th. So altogether, she had 7 ounces of cake. So let's apply that definition shortcut to these 3 examples. So a to the m times a to the n. A is my base, and I'm simply going to add my powers. This is going to be the same as a to the m plus n. The next example, we have 2 to the 4th times 2 to the 5th. So Alice is eating base 2 cake. It's the same as having 9 ounces of base 2 cake, 2 to the 9th. And on this last example here, I want you to understand that, again, 2 has a power of 1, and the 6 has an exponent of 1. 2 and 6 are not exponents. They are not bases. They are coefficients. So the 2 and the 6, they move out front, and they are multiplied times each other. And now the base, the type of cake Alice is eating, is x. X to the 3rd and x to the 5th. We don't know how much greater she will be, but she had 3 ounces of base x cake and 5 ounces of base x cake, and so she had 8 ounces of that type of cake. And so then we take that one step further. 2 times 6 is 12. So it's 12 times x to the 8th.